Okay, so we've got this equation, which is just your loop equation for this circuit. Okay, your total voltage change is this across the resistor, this across the capacitor. Okay, where Q is the charge on the capacitor, and dQ dt is the rate at which charge is moving onto or off of the capacitor, which is the current. Because the only way you move charge onto or off the capacitor is to transfer it from one plate to the other. In this case, you don't have a source of EMF, although we could easily add one. It's not that hard to solve that, right, Ela? But we might or might not do that. Might or might not worry about that. We certainly aren't going to worry about it today. Okay, so basically, if you put a wire and some resistance between the plates of the capacitor, charge is going to flow from the positive to the negative plate. Okay? Simple enough. So, one way to solve this equation is just to use separation of variables. You learn to do this in calculus. dQ dt equals negative Q over RC. Rearrange it like this with the Q's on one side and the T's on the other side. Integrate, and you get your solution. Okay? And you should do that. It's an exercise. You don't want to go off into more advanced courses not knowing how to do even first semester calculus, right? You know how to do it, but you got to review it, and you can't be stumbling over it when you get there. So you want these techniques. Okay, so another method, more general, is okay, now where else have you seen lambdas? You've seen them in this course, but you've certainly seen them in linear algebra. They're eigenvalues, right? Okay, so really we're doing kind of an eigenvalue equation here, whether it looks like it or not. So you kind of want to keep that idea in mind because everybody's always confused about what eigenvalues are in physics and stuff like that. Now, yeah, it comes a little later, so I'm not going to belabor it too much, but I'll make some comments on it, okay? So you assume Q equals AE to the lambda T. Plug in, and I'm going to let you do that step, but I mean, what's dQ dt? It's lambda AE to the lambda T, right? Okay? And of course, Q is AE to the lambda T. So what you're going to get, dQ dt is going to have a lambda AE to the lambda T. This is just going to have an AE to the lambda T. You can divide the AE to the lambda T out of both sides, and you get lambda R plus 1 over C equals 0. Plug in, I should say, simplify. So you just do the derivative, put it here, and divide both sides by AE to the lambda T. You get this. So that lambda equals negative 1 over RC. Thus, Q equals AE to the negative T over RC, which is exactly what you're going to get when you do the details of this. Okay? There's our solution. Make sense? The mathematical steps are very simple. I'm going to ask you to make sure you plug this into here. But you're going to get used to doing that anyhow, because in a minute I'm going to have you doing it with a second order equation. Okay? It's no harder, except that you get a complex valued solution, so you got to know Euler's identity. We've talked about it. I hope you know it. If you don't, you'll need to know it next time. Okay? Very simple. E to the I theta is cosine theta plus I sine theta, right? You should know how that comes out of the Taylor series and all that stuff. Taylor series with sine and cosine and the exponential. Okay, anyhow, you integrate this. Well, if you do the details of this, you end up with the same thing. You get natural log of the absolute value Q equals negative T over RC plus a constant. And I'm going to use, I don't want to use C because even if I write it small, it's going to get confused with the big C. Okay? Don't want to use K, so I'm going to use, oh, what the heck, gamma, although that has implications for stuff Elam's doing. Okay? It's often used as a constant for drag coefficient stuff. Okay. This rearranges to Q equals E to the negative T over RC. The absolute value Q equals E to the negative T over RC plus gamma, which equals AE to the negative T over RC, where A equals E to the gamma. It's using your laws of exponents, simple algebra. Okay? And of course that's greater than 0. But this is an absolute value of Q. You know that from that we had an absolute value here, right? Okay? It's an absolute value of Q, which means that Q equals AE to the negative T over RC. And if A not equal to 0, because if A was equal to 0, Q would just be 0, and you'd already know it. Okay? So, very simple steps in here. You should understand that mathematics, because this is, you know, from here to here is just pre-calculus. From here to here is just very simple calculus. A couple of simple antiderivatives. Okay?